Hello everyone, in this tutorial we are going to provide a solution to this interesting absolute value inequality. We asked to solve the absolute value of 2x plus 1 divided by x plus 1 greater than 3. First of all, let us find the critical points. The first critical point you should consider is when the denominator is 0, because we don't want that situation. And the only value of x that can make the bottom to be 0 is when x is negative 1. So we can see that x cannot be negative 1. This is one of the critical points we should consider, right? Then next, we are going to take the input here and set it to be equal to 3 and also negative 3. Let's do that. Let me start with positive 3. We're going to consider 2x plus 1 divided by x plus 1 to be positive 3. Let's solve. By cross multiplication, we're going to take the whole of this and multiply by this. That will give us 3x plus 3, right? Equal to, you can rationalize this. This times 1 will not change it. So we have just 2x plus 1. 2x plus 1. Let us collect the like terms. If you take this one to the left, it becomes negative. So we already have 3x minus 2x. That will give us 2x. No, sorry, just x, right? Then you can take this one to the other side, which is going to transform it to negative. 1 minus 3 is negative 2. So we have x equal to negative 2. Now remember, we're going to set the same input, 2x plus 1 divided by x plus 1 to be negative 3. Why do we choose negative 3 and positive 3? Irrespective of the sign, whether negative or positive, the absolute value will always transform it to positive. So we are considering either negative 3 or positive 3. So let's solve. We have 2x plus 1 equal to negative 3x negative 3. Let's collect the like terms. If you take this one to the left, it becomes positive. 2x plus 3x is 5x. Equal to, you take 1 there, it becomes negative 1. Negative 3, negative 1 is negative 4. You divide both sides by 5. You have x equal to negative 4 divided by 5. So this is another critical point. Or you can write it as x equal to negative 0.8. All right. On number line, this is my number line. Let's start with the smallest or the biggest. The biggest is 0.8, right? Because we have three numbers here. Negative 0.8, negative 1, and negative 2. So if we have negative 0.8 right here, we could have negative 1 down here and negative 2 here. If you move to the left, we have negative infinity. We have positive infinity to the other side. I'm not going to test for these three numbers because I know they will not satisfy the inequality. But had it been the inequality is greater or equal to, I know that the critical points will satisfy. So instead, I'm going to test for some numbers in between the critical points. So if I should come here, in between here, I could have negative 1.5, right? This is a value I'm going to test. And if you move to the left-hand side of negative 2, we could have negative 3. In between negative 1 and negative 0.8, we could have negative 0.9. And to the right-hand side, let's choose 0. Okay? So I'm going to test for these three numbers. 1, 2, 3, 4. Yeah, 4 numbers. So where is my inequality? This is my inequality. Let us start with negative 3 here. What happens if x is negative 3? We have negative 3 times 2, which is going to give us negative 6. Then you add 1. The numerator will be what? Negative 5. Then you divide by what? Negative 3 plus 1 is negative 2. Negative 2. Right? But remember, we still have absolute value. This will be equal to positive 2.5. And 2.5 is not greater than 3. So this will not satisfy. So what does this imply? It implies that from negative infinity down to negative 2, no value will satisfy. Then we are going to test for value in between negative 2 to negative 1, which we choose as negative 1.5. We have 2 multiplied by negative 1.5, right? Which is going to give us negative 3. And negative 3 plus 1, that will give us negative 2. So we have negative 2. Divide by the same thing, we have negative 1.5 plus 1, right? Plus 1. That will give us negative 0.5. Remember, we have absolute value. Even without absolute value, the negatives will cancel. So what is 2 divided by 0.5? 2 divided by 0.5, that will give us 4. And you can see indeed 4 is greater than 3. Therefore, it implies that every value between negative 2 down to negative 1 will satisfy. You see that? Then let us check for this one, negative 0.9. If x is negative 0.9, we take negative 0.9, we multiply by 2, right? Whatever we obtain, we add 1. So the top will be negative 0.8. Divide by negative 0.9 plus 1, that is 0.1. So let's divide. Remember, we have absolute value here. That is equal to 8, and 8 is indeed greater than 3, which implies that all points here will satisfy between negative 1 down to negative 0.8. Then to the right hand side of what do we call is negative 0.8, we have 0. So let's test for 0. So if x is 0, the whole of this will be 0. This will be 0. We have 1 divided by 1, which is 1. And 1 in absolute value is 1. 1 is not greater than 3. And hence, to the right-hand side, no value will satisfy. So let me show you 2 different ways to write the solution to this problem. You can see that x belongs to the set of values from where? From negative 2 down to what? Negative 1, because the endpoints will not satisfy. Union from where? From negative 1 down to negative 0.8. This is one way to write it. Or you could say that x belongs to the set of values from negative 2 down to negative 0.8 straight, but minus negative 1. Because remember, when x is negative 1, the bottom will be 0, which is undefined. So this is another way to write it. Or you can use inequality and say that x is from negative 2 down to negative 0.8, excluding negative 1. So let's see how we can write it. We can say that from negative 2 down to negative 0.8, but excluding x equal to negative 1. So x cannot be equal to negative 1. Thank you for watching. Do share to your learning colleagues. Bye-bye.